Hi guys, we have another example over here where we're looking for to solve for x where minus x squared minus 3x plus 5 is greater than 0. So we can really look at this inequality. So notice that the coefficient of x squared term is minus 1. Remember that if we multiply or divide an inequality by a negative number, then the inequality sign changes direction. That's really important. So we can write the same inequality in different ways and still get the same answer as shown below. So you can write your inequality as minus x squared minus 3x plus 5, but the difference is that, so in this case that's really originally it's greater than 0. If you choose to multiply that by minus 1, you're going to have to change the sign of the inequality, right? Now that would be your sign, so you'd have to change the sign of the inequality, right? So minus x squared minus 3x plus 5x greater than 0. So when you're looking at this function and you're looking at where it's greater than 0, this is where it's greater than 0, this point all the way that point. Now when you choose to multiply that by a negative, which is what we did here, you get this function, right? And if you're looking at the same region over here and you're looking for that answer, you realize that for exactly the same region, let me actually draw that region, because this is really important as well. So if you look at this region over here, from this point all the way to that point, in terms of x. So for all that point, our function was above, right? And that's really the solution that we're looking at. We're looking at where minus x squared minus 3x plus 5 is greater than 0, which is this region. Now we've chose to multiply that by a negative. Now that changes our function to look like that, right? So meaning that the region now that we're looking at is now not longer greater than 0, right? So our function here is actually less than 0. That's really the reason why we have to change our inequality every time we multiply, because we flip our function, right? So we flip our function in the x-axis, about the x-axis. So that's why we always need to change the inequality sign. So if you've ever asked yourself why do you have to change an inequality sign, just look at that and really try to be happy with that. That's really why. Okay, anyway, let's solve this business. So we notice that minus x squared minus 3x plus 5 is greater than 0 cannot be easily factorized. So we're gonna slap it in an equation, right? And these are gonna be our x1 and x2 respectively. So if you were to take this business and sort of like put it in a intercept form, this is what you would have, right? So remember in the last parts of I think I did this, so it's fine. When I said you have roots and you have to find the equation, right? So you would first have x1 is equal to so you would first have x is equal to, in this case, minus 4.2, and then what you would have to do, you would have to take the minus 4.2 to the other side, and you would basically have plus 4.2 is equal to 0, and that would be your first it would be your first factor, and then you would have another one, right? Excuse me guys, I do think this is something that we've done before. Okay, anyway, so we're gonna have that in an factors form like that, and we can sort of like determine we can determine our critical values. It's x is equal to minus 4.2 and x is equal to 1.2, right? That's our critical values. I'll skip this table form and I'll go straight there, right? So we're looking at so we chose to take this one where we change our a to be positive, x squared plus 3x minus 5. So we chose to look at, okay guys, it doesn't really matter which one we're looking at, right? So you can see that that and that is really gonna give you the same solutions, you know. Anyway, so we're looking at x squared plus 3x minus 5 where a is greater, so in this case our a is greater than 0, right? And hence we have a smile face and our turning point is the minimum. It's over there. What's important is that you put your intercepts, right? You put your intercepts over there, and then you look at what the question is asking, right? So this is what the question was asking. We were looking for where our function is greater than that, right? But we multiplied by 1, so we're looking for where our function is less than 0. So we're looking at the blue part where our function is less than 0. So we're looking at the blue part, right? And our function, we're looking at where it's just less than 0, right? So guys, I want you to notice something, right? I want you to notice something. So you can see your function is less than 0 for all the values that are between minus 4.2 and 1.2, right? Right, so really our x lies between, x is greater than minus 4.2 and, let me read this properly. X squared plus 3x minus 5 is less than 0 for all the values of x where x is greater than minus 4.2 but less than 1.2, right? So which is really this region. Guys, I want you to notice what's happening. I want you to notice what's happening at what's happening at 4.2, right, and 1.2. Do you see that over there we have circles that are not blue, right? And it's because we're just looking at where it's less than 0. Not where it's less than 0 or equal to 0. So you sort of like open that, you leave those guys open there, right? So guys, I really want this to be an involved sort of like teaching. I don't want you to just hear me saying stuff all the time. So I want you to try. I'll show. I won't go through the next sort of like problem. I want you to look at it. I'll keep it on the screen and I'll slowly go through it. I won't say anything. I'll go through it with the mouse like this. I want you to pause the video as you go on and try to study the example. Probably gonna make this example so long later from now, right? When I've gave you guys a test and I've seen that you're struggling. If you're not struggling, I'm not gonna give this. Okay guys, I'll see you in the next video, right? We're probably going to be looking at, let's see, simultaneous equations. So we're probably just going to be looking at simultaneous equations. Bye guys, I'll see you in the next video.